Next, we are looking at Chapter 8, Sequences and Series. We only focus on the really basic one, so we want to be able to define and identify arithmetic and geometric sequences. We need to be able to come up a few terms for each type of sequences when the first few terms were given. And we need to come up the formula so we can find the nth terms of arithmetic and geometric sequences, and then we will solve application problem using arithmetic and geometric sequences. And on the exam, you can expect to see the application problems for the arithmetic and geometric sequences.
We just look at a very basic one. The first one, we're going to have a, what would that one be? What kind? Pointing up or down? Pointing up, triangle like that. That's it? No? What else do I need to do? Shade it in, okay. The next one? Point it down. Do I need to shade it in? Yes. The last one would be a square. Are we okay with this? It's not going to be on the exam, okay? This one is a little bit too easy. But the next few maybe. Alright, the first one say 2, 5, 8, 11. How do I get from one term to the other term? We are doing what? We are adding 2, so we have to check 2 plus 3, okay? Plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11. So it looks like the rule is you add 3, right? And what would be the next 3 terms? 14, 17, 20. So for an arithmetic sequence, what you do is you are going to add the same term again and again, add the same number again and again to get the next term. Okay? How about the next one? It looked like multiply by 2. Like if we only look at 3 and 6, we are like maybe adding 3, but 6 plus 3 is 9, not 12, right? So it's not adding. So this is times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. What would be the next 3 numbers? 48, 96, and 192. So the rule for this one seems to be multiplying by 2. So for geometric sequence, this is saying if you multiply the same number again and again, to get the next term, then those kind of sequence are considered as geometric. Are we okay with that? Okay, how about the next one? What's happening with the next one? 1, 4, 9, 16. What do you think the next few will be? 25, 36, 49. So how do I get those?
So we want to think about how do we get from 25 to 36 to 49. So if we're looking at the patterns right underneath there, we can see from 1 to 4, we are adding 3, right? From 4 to 9 at 5, from 9 to 16 at 7. So it looks like that they are adding consecutive odd number, right? And if you look one layer below that, there are 2 units between each of the number. So that's some kind of patterns going, and some of you may also notice they are actually special number. Like the first term is like 1 by 1, so it's just equal to 1. The second term is like 2 by 2, 2 square equal to 4. And then the third one would be like 3 by 3, so it's like 3 squares, which is 9. Those are our square number, right? So if I want to know the 10th number, the 10th term of this, it would be just 10 into 2 square, right? So it would be 10 times 10 equal to 100. If we're looking for the 100th number, it would be 100 square, right? Which would have 4 zeros. And if we want any term, the nth term, basically just n squared, right? So this is one of the special one. So we talk about arithmetic and geometric. And the next one, we're going to want to see if we can come up with a formula which will do the arithmetic and geometric sequences. So next we want to come up with a formula that will be able to calculate the nth term of arithmetic sequence. So we're going to use the sequence we just did because we know the number, right? So we have 2, 5, 8, 11, 14, 17, and 20. And we're going to do some analysis by writing down the first few terms. So we have the first term, second term, third term, fourth term. The first term was 2, and then we have 5, and then 8, and then 11. So we need to check a few terms. If you feel more comfortable doing more, that's okay. I'm going to start with just 4 terms. So I want to see how do I get from one term to the other. So the first one started with 2. The second one, I'm going to write down the previous term and then get to 5 by adding 3. And then the next line, we're going to copy what we have from the last one. And then that's 5. To get from 5 to 8, we need to add another 3. So the next one would be write down what we have from the last line. 2 plus 3 plus 3, that's 5, that's 8. 8 to 11, we need to add one more 3. So now we're going to need to clean that up. I can see all the terms start with 2 plus 3, right? And the one we just did have 3 of the 3, so it's basically 3 times 3, right? And then the one before that start with 2 plus 3, and this time I only have 2, right? So times 2. And then it would be 2 plus 3. I only have one of them, so times 1. And then the very first one, it would be 2 plus 3, but I don't have any 3, so basically I need to multiply by 0. So that still check out, right? 3 times 0 is 0, plus the 2, just 2. So after we write all this out, hopefully you can see there is a pattern. The pattern is all this for this particular sequence start with 2 plus 3. And then when you are on the fourth term, you times 3, third term times 2, second term times 1, first term times 0, right? So basically, whatever you're multiplying is going to be 1 less than the term. So hopefully you see that. And if they ask you to find the nth term, then again, for this particular sequence, I need to start with 2 plus 3, right? And what are we multiplying? So it's supposed to be 1 less than the term, right? So this is nth term, so we need to multiply by n minus 1. Is that okay? So in general, for the arithmetic sequence, if you need to find the nth term, the formula is you use your, so this is a to the nth term, you will use your first term plus, this is the difference between them, so we use d, and then n minus 1. So first term, the nth term equal to first term plus the difference times n minus 1. So I don't want you to need to memorize it, but that's how the formula was coming from. Okay, so that's the nth term, and then we need the 100th term, so we just do the same thing, right? So we need to find the 100th term. this sequence particularly is starting from 2 plus 3, right? And then I need to multiply n, which is the term, we have 100, and then minus 1, right? So 100 minus 1 is 99. Make sure you follow the rule of operations. 2 plus 3 times 99. So it's kind of like times 3 times 100, but need to subtract 3. Or you can use the calculator. So basically 2 plus 297. Together we have 299. So that's how you come up with the nth term or any term of an arithmetic sequence. So on the test, I could give you a question with the first few terms, and you need to find the next few terms. Tell me what the rule is for this particular sequence. We add 3, right? That's the rule. And then I will ask you to analyze it and come up with the nth term formula, and then also found a specific term. So you could see something like that on the exam.
So the next one, we're going to the geometric sequence, which we did one earlier. So we have those numbers, right? So we're going to fill out those numbers on that geometric sequence. And we had 48, 96, and 192. So we're going to do the same thing. We try to analyze it a little bit. The first term is 3. Second term is 6. Third term is 12. Fourth term is 24. So 3 is just 3. To get from 3 to 6, what did I do? 3 times 2. So copy from the last line, 3 times 2 is 6. I need to do what to get 12? Multiply another 2. So copy what we have from the last line. And that's 12. 12 need to multiply one more 2 to get to 24. So to clean that up, this time, all the sequences, all of these started from 3 times 2, right? But how do you write 2 times 2 times 2? This is 2 to the third power. And the one before that would be 3 times 2 to the second. And then 3 times 2 to the first. And the very beginning, we have 3 times 2 to the 0, because anything raised to 0 power is 1. So hopefully you can see the pattern. The exponent is going to be 1 less than whatever term that is. Very good. So we have that. And if they ask you to get the nth term, n term from this sequence is still starting from 3 times 2, right? What power should I raise that to? Nth. It would be n minus 1 is correct. So the actual geometric sequence formula say if you have a to the n term equal to the first term, and then the rates raised to n minus 1. So that's the official formula. And the next part, they ask you for the 100th terms from this sequence, still starting from 3 times 2, right? This one is going to be raised to 99 because it's 100 minus 1, right? So it's going to be 3 times 2 raised to 99, which is a very big number, so I'm not going to multiply it out. So this could be your answer. If you put it on a calculator, it will show like this number is huge.